We can start now, Vinodini.
Um, Good evening, everyone. I hope you're all doing well, and welcome to yet another exciting session on Career Fair. My name is Vinodini, and I'm here to welcome you all on behalf of Guvi. And today's session is going to be on from attention to action, understanding the impact of transformers in AI. And where you will learn about the transformative power of transformers in AI, real world applications and case studies, the future of AI, and the role of transformers. And we will also have a Q&A session during the meet, and please find the Q&A form in the description below, and please post your questions over there. And without further ado, I'd like to introduce our guest, Miss Chandnika R. And Ms. Chandika R is an accomplished AI research professional with a strong background in natural language processing and deep learning. And she holds an MS in computer science with a specialization in AI ML from Wolf University and BE in computer science from Anna University, where she was awarded the university silver medalist. So, in her current role, at Verizon India, Chandnika has demonstrated expertise in developing cutting edge AI solutions. Noteworthy accomplishments including leading the research and development of the document question and answering model for a chatbot, incorporating generative AI models such as Llama 2 and LangChain, and handling large volumes of private organizational documents. So, Chandika's contributions extend beyond her corporate role as she actively engages with the global AI community through her involvement with Cellstrat Hub as an AI community research contributor. And her achievements have been recognized through various awards, including being ranked as the second best research paper presenter at the Verizon Tech Day Generative AI event. So I'll now hand over the session to our guest, and I would like to welcome her. Hello, Chandnika.
Yeah, hi Vinodini.
Hi, how are you?
I'm doing great. Thanks for the lovely introduction.
Thank you. Thank you for coming. And the floor is yours. You can proceed.
Sure. Let me share my screen.
Yeah, sure. Go on.
Hope it's visible.
It's visible now.
Yeah. Hello everyone. Welcome to the session on transformers. Firstly, congratulations to everybody here to have started to upskill in this field. So it's the most exciting phase to be in AI and mostly in natural language processing because of all the boom happening in transformers phase and chat GPT phase. So let's get started on this topic. So in today's session, we will be mostly covering on the transformers technology and some of the cool applications that are possible after this advent of transformers. And also we'll do a friendly, beginner-friendly introduction into this transformers architecture. So at any time, if you have any questions, please feel free to post in chat. We will also try to have a Q&A section in the last. Okay, to start with, let's start with a small game. So can I know will I be able to see the chat box, the response from the participants? Yeah. All right then. So this is a small game where you will have to identify the famous celebrity. So whichever celebrity you can identify, you can just know in the chat box. So we will have 5 more seconds, 5 more seconds to think about it. Maybe some famous celebrities come into your mind. Five, four, three, two, and one. Let's reveal the answer. So the answer is none of these are real human faces. All of them are AI generated images, right? So look at the quality of these images. They are so realistic and they are so real to and as close as the human face, right? So this is the quality of the current transformers model, and this is the capability, and AI is not a future technology anymore. It is happening right now, and it is presently making a lot of wonders and a lot of transformations are being processed. So with this, let's start from the basics. Let's first try to understand about these technologies. Let's start from the scratch. So let's try to understand what AI is all about, right? So you might have, undergone a lot of webinars. You might have your own definition of AI. Let's try to, simplify what AI is actually trying to do. So AI refers to artificial intelligence, where we are trying to create a simulation of human intelligence in machines, right? So we are trying to develop human level intelligence to a machine. We are trying to give human level decision making skills, communication skills, natural language understanding skills to a machine, so that the machine will be able to take these decisions, and they will also be able to forecast depending upon the data. Like how we humans learn from the patterns, we learn from the society, from the culture, from a lot of examples that we are seeing, right? The same way this AI systems will also learn from multiple examples and multiple data, and they will try to act in the same way like we humans usually do. So, this AI technology is completely transforming multiple industries, including telecommunication, e commerce, or mobile shopping, or any industry we take. AI is already making a very big revolution. So under AI, we have multiple subfields, right? So these are all the major subfields within AI. So within AI, we have two major subfields, which is machine learning and deep learning, right? So some of us might be having confusion. Sometimes I'm hearing about the word AI, sometimes it's about machine learning, or in some papers it's mentioned as deep learning. Are they all different or are they same? So we might be having these questions, right? So the answer to is all are just the same. AI, machine learning, deep learning are all same, but they all differs with small nuances, right? The techniques with which we implement, for which use case we are applying these fields, all will differ. So to make it even more simpler, right? So we have science and we have physics. So in our school grade, we all would have studied physics, chemistry, biology, all those things. So if I ask you a question, is science and physics different? What will you say? Science and physics are not different, right? They are just the same. In the same way, artificial intelligence could be considered as science and machine learning could be considered as a physics. Like physics is a subfield of science, machine learning is a subfield of artificial intelligence. Likewise, deep learning is a subfield of machine learning and machine learning is a subfield of AI. For example, we would have had subjects like botany, zoology. Like botany is a subfield of biology, and biology is a subfield of science. In the same way, we have three different terms which are subfield of one another, right? So, with this, we are going to focus on one technology, one particular implementation, which is deep learning. So, this deep learning is doing a lot of revolution and it has been a very big game changer. So, for today's session alone, we will be focusing on this deep learning topic, right? So, what is deep learning? So, any idea on what is deep learning? Have you heard about this term? Okay, so just give me a minute. Hope my screen is visible again.
Yes, it is visible.
Okay, yeah, thank you. So I see awesome responses from most of you. Most of you are mentioning about neural networks. Deep learning is having neural network. So most of you are having great knowledge on it already. Good to see most of your responses. So Kumar says it's a subfield of machine learning with multi-layered neural networks with complex decision-making skills. Awesome. So to simplify, right? To simplify, what is deep learning is all about? It is a subfield of machine learning, yes, but it takes care of all the process that was involved in machine learning, right? So it resonates the functioning of human brain. So this technology was developed from the inspiration of a human brain. So that's why it is sometimes called as a black box technology. Why? Because if we take the human brain, right, maybe we can claim that we have understood the functioning of the human brain, we have understood the working of human brain, but in the reality, we ourselves doesn't know how our human brains are working. Yeah. So to define deep learning, I hope my audio is clear. I think there was a disconnect in the middle. Hope my screen and audio is clear. Awesome, yeah. Sorry for the disconnect. So let's continue with that. So to define deep learning, right? To understand about deep learning, let's first try to understand about human brain. Because a lot of scientists have done and trying to understand the working of human brain, how it is actually functioning, what is the inner working of it, right? So to understand about human brain is made up of multiple neurons, as we all know. So it has lot of neurons and lot of network connection, and when one event occurs, lot of activation is happening inside our brain, right? So when you have free time, just take a look at the functioning of the human brain. It's such a fascinating, interesting field. So it's definitely worth giving it a read. So to make it in a very short note, so in human brain we have multiple neurons, and they are connected using networks similar to a neural network kind of a structure. So when one event happens, according to the multiple learnings that we had, according to the multiple situations and experience we have had, certain part of it will get activated, and this is how the communication will happen between the neural networks. So we are trying to replicate the same in using the mathematical algorithm. So this technology is called deep learning technology, right? So how we have a neural network in our human brain, the same thing where if we have replicated using a mathematical algorithm, it is called the deep learning technology. So what is happening inside our human brain? Can we really define it? No, right? So if, for example, if I ask you a question, like could you name your most favorite person, and you have to tell me five reasons, right? So five reasons of why do you like that person. maybe you can come up with five different reasons. But if I show you a different person with the same five characteristics, will you be able to like the person with the same intensity? That's really not possible, right? So we ourselves doesn't know why do we like a person, why do we dislike a person, what is happening in different situations. We ourselves cannot consciously say, something is happening subconsciously, right? So in the same way, something is happening inside these neural networks which produces the output. So the similar thing we have simulated using the mathematical algorithms. So this paves the foundation of deep learning models, right? So maybe in the upcoming modules, in the upcoming sessions, we will have a deeper dive into this deep learning, which is the most interesting field. So for now, to understand, just understand that deep learning is similar to the human brain functioning. It is a black box model. It will learn from multiple examples it's been shown, just like our humans, right? Awesome. So in today's session, we will focus on this deep learning technology. All right. So what are transformers, right? So, has anybody heard about this term transformer? Maybe not about the movie Transformer. In NLP context, the word transformers. Awesome. I see a superb response on this. Yeah. So, you people are already pro in it. All right. So, can you think of any recent viral example? Some product that went so viral in the history of internet. Any viral example? Yeah, awesome. Yeah, Akash, Rahul, you have guessed it right. So, one viral example of this transformer technology is Chat GPT, right? So I don't have to give any introduction about Chat GPT, any advantage, functionality, how it is working of Chat GPT. I hope almost everybody here would have tried Chat GPT, right? So Chat GPT has made a very big boom, and it has revealed about the interesting facts about transformers to the general public. Everybody, most of the public have already tried ChatGPT, and it is so much accessible, and we are already witnessing the powers of transformers, right? So ChatGPT is enabled with this transformer technology. So this technology is what we will be doing a deeper dive today, right? So how many of you have tried ChatGPT here? Like, is there anybody who hasn't? If you haven't tried it, it's high time you should definitely give it a try. So there are multiple other examples or multiple models that have evolved from ChatGPT, from the GPT models, right? So this is definitely a product that is worth going viral, and this has made the AI boom possible, and many people have come to know about the beauty of transformers from this particular product. Awesome. So today we will be digging more about the technology behind this model. So the last word T, right, in GPT, stands for transformers. So transformers is the foundation of this Chat GPT model. We'll be digging a deeper dive on that today. All right. So before going into what transformers is all about, right? What is a transformer into the technical part of it? Let's first try to understand what transformers can actually do. So one example we saw was ChatGPT, right? So ChatGPT was the thing which made this transformer, so popular among the public. There are multiple other functionalities and multiple other applications of transformers, which we will try to understand now. So can you think of some examples? So what do you think, like any recent AI tool which you have witnessed, do you think that could be an example of transformer? Can you, if you think of any other examples of transformers, you can send in the chat. So few of you have already guessed it right. About the generative AI is definitely powered by transformers technology. So for generative AI, transformers is the base. It has laid the foundation, right? So we'll try to understand some of the cool applications of transformers. So this is one interesting application of transformers with the deep learning technology from text to image conversion, right? So these images are created by a model called Imagen, right? This model is from Google called Imagen. So here, if we give a prompt, like how you talk to a chat GPT, whatever you are talking to chat GPT, each is considered as a prompt, right? So everybody here are a prompt engineers already. So like the same way I'm giving a prompt, like a small cactus wearing a straw hat and neon sunglasses in the Sahara desert. If you see the third image over here, it has captured all the features I have mentioned in the text and it has generated this image. It is a small cactus wearing a straw hat, wearing a neon sunglasses, and background of a Sahara desert, right? So from this very simple text, it has generated this image on its own. No image editing, no Photoshop, no sophisticated tools used. Just I have to talk in English to this model, which will generate these beautiful images. All of these are generated using transformer technology, right? And these are so close to as like a human be creating in a Adobe Photoshop or any other sophisticated tools, right? So this is the quality of these transformer models, right? So there are many paid and also free versions available. You can definitely try this Imagen model or other features or other text to image tools available in the public. This is an interesting application of transformers. So another thing what transformers can do is it can generate a lot of text, right? So one viral example of this is ChatGPT, which we all have already used. So it can generate a lot of text. It can even write a very big blog post, right? So it can write a Twitter post. It can write a detailed technical content generation. Even if we give a single keyword to it, it can generate a whole big chunk of text out of it. So this is the power of transformers. I think this particular feature most of you would have already tried. Even if you give small prompt to ChatGPT, right, it can create a whole big text out of it, right? Our input is so small, but the output from the ChatGPT is almost a page, right? So that is the power of transformers. So another very interesting and a creative application of ChatGPT is not just it can convert a text to text, but it can convert from text to music. How interesting this is, right? So from a text, it is completely converting it to a different format. It can generate musics that are so real. We can't even differentiate that this was generated by a system. This was generated from a AI model. For example, this is called Music LM from Google Test Kitchen. You can try this in your free time. It's called Music LM. So, for example, if I give a text prompt, so prompt is nothing but a way to talk to this model. So earlier we were talking through programming languages, right? We had C program, C++, Java. Through multiple programming languages, we were talking to the computer. But now we are talking to the computer in a very plain, simple English. So all those are called prompts. And everybody here is already a prompt engineer, as I mentioned. So likewise, I'm giving a prompt like dreamy, ethereal, melodic, chill vibes indie pop. And using these keywords, it has generated beautiful music capturing all these features, right? So this is such a cool and innovative application of transformers. So I have included a video about it. So this is from Google AI Test Kitchen. So they have invited few of the music artists to try it out, and they are so fascinated about the power of these transformer technology, right? So let me try to play this. Let me know if you can hear the audio, or if not, check this video later. It's available in Google.
So MusicLM builds on top of AudioLM, which is a broader audio generation algorithm. And what MusicLM does is taking this very powerful audio generation algorithm, train it on music data, and add specific controls for music creation, such as text.
So just to mention what it can do, right? So in this video, this artist will just hum the music of Bella Ciao, right? So Bella Ciao is a famous song from Money Heist. So this artist will be just humming this Bella Ciao music. So what the
Na na na
transformer
na.
does, it will convert it to a real jazz with saxophone Bella Ciao song itself. So that's how powerful these transformers are, right? So definitely, try to watch this YouTube video. It's so interesting. So this is one of the great, achievement in transformers, pathway. And what else can it do? No, how can we utilize this? So this is also one another example where we can use it for text summarization. So text summarization is also one of the important use case in deep learning. So we are using transformers to achieve this. So this is a tool called node gpt, where if you paste the YouTube link, right, it would create a summary out of it. So I have pasted a 45-minute long YouTube video about OpenAI keynote. So instead of me watching this 45-minute video, if I just paste the YouTube link, the transformer would go through it and it would create a quick summary out of it, right? So from video, it is creating a short summary. From 45-minute content, it has generated a 1 minute summary for me. So this is the power of transformers technology. So likewise, we have multiple other applications possible with transformers, and this is a recent technology. Only in the last decade, this has become a very big boom, and we are seeing a lot of possibilities happening. So likewise, we have code generation in the GitHub Copilot. If I give a text, it will convert it to a code, right? Earlier we saw like text to text, it can convert, text to music, it can convert. Now from the prompt I'm giving, it is able to generate a code itself. Whatever language we ask, it is capable of generating it. So if any code developers, someone from programming background, definitely do check this GitHub Copilot or Duet AI from Google, right? This is definitely a game changer, and this will definitely be a part of developers life cycle. So definitely do try check it out. Also, you will definitely understand the power of these transformers. So has anybody tried this code generation tool? Even in Google Colab, we have a free code generation thing. How many of you have tried this code generation? Awesome. So definitely, if you haven't tried some of them, you can try this Google Colab, GitHub Copilot, or Do It AI from Google. It's so transformative. And this is a very interesting and a recent release from OpenAI, like how they did a revolution in text generation using ChatGPT. This is a game changer in video industries. So this is a model from OpenAI called Sora. So this is based on the transformer technology again, and this is capable of generating videos, right? From text to video, it is capable of doing it. So look at the quality of these videos. It can generate videos of a puppy. It can generate real forest-like videos. So the text that you are seeing, right? All of those are prompt. This is the prompt we are giving, and from the text, it is getting converted to a video. How magical this is, right? From a simple, plain, natural language English, the output is a video. Look at the quality of these videos. And whatever they have mentioned in the prompt, everything is being captured in the video. The gaming industries, the video industry, the entertainment industry, everything are going to get transformed using these technologies. So transformers is the base of all of these applications, right? So transformers is presently revolutionizing multiple things, and it is definitely the game changer in the future implementations as well. All right. So, with this context about transformers, right? Let's dive into the understanding about these transformers. These all look so promising, right? Let's understand the technology behind these applications, right? So I hope you all are excited about learn about transformers now, right? So, how many of you are actually excited about knowing about the technology behind these applications? Cool. So Transformers is the simple architecture, but it is so powerful that it has no made a game changer in these industries. So what are transformers, right? So what is a transformer actually? So transformer is a model which transforms one sequence into another, right? As its name suggests, its main motive is to transform one form into another, right? So here in natural language context, it is converting from one sequence into another sequence. So what do I mean when I say transform? What is it actually transforming, right? So if we take translation from English, it is converting to a French. If we say code generation from a text prompt, it is converting to a code. Or maybe the video example which we saw, from a simple text prompt, it is converting to a video output, right? So the input I am giving is a text, but the output I am getting is into a different format altogether. It is a different sequence, from text to code, from text to video, from one language to another language. It is capable of transforming, right? So whatever examples we saw previously, the transformer was doing the same thing, right? It was transforming from one form to the another form, right? So this is the core concept of transformers. It is basically for transforming into another sequence or another format. So to understand about transformers, we need to understand about two things. So transformers has two parts in it. One is the encoder and second is the decoder, right? So the basic meaning of encoding, decoding, the same gets applied here as well. So encoder is the main functionality of the encoder is to encode the sequence, right? For example, it works mostly on the input sequence, we would have studied about the cryptography, right? Or the basic thing, like from a English word, using cryptography techniques, we can convert into a different form. Maybe we would have played these games like there will be a English sentence using something, we have to convert it into a secret code which we, our friends, will only understand. So the same way these encoders are converting a sequence into an encoded form so that this decoder will understand, right? So this encoder's main task is to work on this input sequence, and the decoder's main task is to work on the output sequence. So the English thing, whatever English language we are talking, the computer will not understand, right? So the task of this encoder is to convert the natural language we humans are talking into a format that this encoder will understand. Not only that, it will give even more better insights about our human language. What are we trying to convey? What is happening in the world? So all of these, it will try to do in an encoded format so that this decoder will understand in a better way, and the decoder will work on it, and then it will give a output. So we will see all of these in detail, but just try to understand that in transformers we have two things: one on the encoding part and the second on the decoding part, right? So for example, when I mentioned that encoder is focused on the input sequence, for example, if I ask you, how are you? Your response would be, I am good, right? So imagine if this middle thing is our human brain. The green thing you're seeing is the encoding part where you will receive my input. My input to you is, how are you? Right? So the input will be received, some processing will happen, and depending upon the learnings that you had, based upon your experience, based upon your language understanding, based upon your teaching, your your way of greeting a person, from these you will respond me that I am good, right? That is what a decoder does. To receive the input that I am giving you, which is how are you, you have some mechanism within you, like you have ears, you have human brain processing, and within the brain there are multiple areas to receive the input. So all of those will come here, and my sentence, how are you, will get converted to a form, and then it will go to the decoder, where it will process based upon your learning, based upon your previous experience. You will say greeting us, I am good. You will respond to my greeting us, I am good. Right? So this is all about encoder and decoder in a simple format. Right? So this is the base of transformer. There are two different parts within the transformers. Right? So is this clear? Like the encoder decoder part? The encoder is to receive the input and convert it in a way that the decoder can understand. And the decoder, from its past experience, will give a output. For example, the input could be, how are you? And the output could be, I am good. Right? Cool. So likewise, we have two phases in transformers, right? So one we call it as pre-training, and the second we call it as fine-tuning. So I think for most of us, this term would be a new term, right? So what do I mean by pre-training? So in pre-training, we are first trying to make the transformer understand about a language, right? So maybe for example, if I have to learn about a new language, I might refer to multiple books, I might watch multiple movies, I might interact with multiple people, and or even I might just listen to a conversation, right? I might be listening to a different people's conversation. In the same way, in the pre-training, we are just showing the model about multiple different books, multiple different sources, multiple different papers to understand about the language, right? Within language, there are a lot of grammars happening, there are a lot of subtle nuances. One person might mean in a different way, the other person might use the language in a different way. So all of these nuances about a language is captured in this pre-training phase, right? So, what is fine tuning then? So, in the first step, which is pre training, the model has learned about the language, not just the spelling or the grammar, but the nuances in the language, right? Maybe in the Tamil language, we talk in a different way. Maybe in the Hindi language, we might refer in a different way. Or even within a particular language, one person's way of communication is different, another person's way of writing is different. So, all these multiple things, like how we human have learned through all these years of experience, right? We are feeding the same thing with multiple iteration, multiple training. The model is also learning, right? And then with this pre-training happen, I will fine tune my model on a particular task. For example, I might fine tune it for translation, or I might fine tune it for summarization. For example, if I am if I want to learn a new language, like for example, German, if I'm interested in learning a new language, German, the step one, what should I do? I should learn about the language. I should learn about the cultural things in the language. I should learn and listen to multiple conversations, right? So after learning the German language, maybe I could become a translator. That will be my fine tuned task. I can pick up a job as a translator, which is my step two. Or I can become a summarizer. If somebody is giving me a German newspaper, my job is to read it and summarize into a one paragraph. Maybe I might pick that job, right? So these specific jobs is what I mean by fine tuning. That is the step two. Clear? So this is the difference between pre-training, fine-tuning. Pre-training would be the step one, which involves a lot of time and lot of computing power is required. But once this step is done, I can fine-tune myself into a specific job. Likewise, I can fine-tune this vast model into a fine-tune task like summarization or translation, right? So this is about pre-training and fine-tuning in transformers. So that's why we call transformers as a semi-supervised learning. So in the pre-training phase, we need not give any label. We just have to show it some books, some newspapers, some articles through which it will learn the language. But in the fine-tuning task, we have to say step by step what are we expecting, what are the specific things it has to do, what is the output that is expected from the model. So this is a like a teacher-student method of learning. But this is something like just by observation, just by going through multiple texts, it will learn. So now comes the big question, right? Why are Transformers a big hit? Right? So why do you think Transformers are such a big hit? There have been multiple models earlier as well, but we are hearing a lot about GPT, Chat GPT, lot of recent models, and earlier also we had BERT models. So why do you think Transformer is a big hit? Whatever comes to your mind, just post your thoughts in the chat section. Let's try to keep this session more interactive so that you will also retain the information for a longer time. Just post your thoughts in the chat. No, what do you think could be the reason that this transformer has become a major hit? All right, so before seeing that, right, shall we play a small game again? This is a very simple game which we would have, it was a syllabus in our school grades, reading comprehension, right? So this is a small paragraph, and I have five set of questions based out of the paragraph. So you will have to read the paragraph and answer these questions. Maybe in some competitive exams also we are having this reading comprehension, right? So let's see who is answering it first. So the question number one is, what did Mr. Frank press? All right. So let me reveal the response. So, without focusing on the response, let's try to understand how our brain is functioning on this, right? So, can anyone mention, not on the answer to this, but how did you try to solve this question? What was your approach in solving this question? When the question is, what did Mr. Frank press, what was your brain processing, what was your approach in solving this? Right. So most of us, what we would do is, instead of going through the entire paragraph every time, we would be focusing on particular portion of the paragraph, right? Only on the particular thing we'll be focusing. What did Mr. Frank press? So I would be just gazing around and I would notice this word Mr. Frank and then press, right? And then I would derive the answer as the white liver, right? So the same way, the neural networks are also trained to do the same way. So this approach we call as attention, right? So for this particular question, where did my attention go? It went only on this particular area. Because of the words Mr. Frank pressed, Mr. Frank pressed was being present, and my attention went only to this particular area, right? So this is the very very important concept behind transformers, and this is why transformers has revolutionized almost everything in the NLP space, right? So this simple technique which we humans are following, the same thing when we have tried to put it in a machine, that's what has been a game changer, right? So I think this is what most of you would have also tried to do, right? So the same attention technique. This is what almost everyone here would have made the approach. So this is what transformers are also doing. So let's try to understand about this attention first, right? So there is also a another alternate name for transformers which they call attention mechanism, and even the paper of transformers name is attention is all you need. I think most of you would have heard this paper's name. If not, you'll try to do a walkthrough of the paper today. All right. So this is a game again. You will have to give a caption for this image. Imagine, for example, you are uploading this image in your social media like Facebook or Instagram. Now you will have to enter a beautiful caption for this image. Or maybe consider, I'm going to upload this to my Instagram. Can you suggest a good caption to this image? And you should also explain on what basis did you create that caption. So you can also explain like what is the approach you're taking to when you freshly look at this image, what is the approach you're doing? Like how are you processing this image? So mostly you would be thinking about this girl. There is a tree behind. It is a grass behind. There is a frisbee. It's a young girl. So all of these only we will notice, right? So this is how our brain will also process. So will you capture in this way? Like there is a grass here. There is a grass. There is some trees. There is a space without the grass. All of these will you consider, or will you consider this way? Our main attention would be on the girl and on the frisbee, right? Not this, there is a grass in the left, there is a grass in the right. All those are not important to us, all those are not significant to us. But the major focus where our eyes will go is on the girl and on the frisbee, and then she is throwing and it looks like a park, right? So this thing is called attention mechanism. If I give you an image like this, our brain would mostly focus that there is a girl, there is a frisbee, instead of focusing on the insignificant parts of the image, right? So this is the main concept of attention. So did you also process the same way when you first saw the image? Usually, yes, right? This is how our brain will also process. We would focus only on the important parts of the image rather than focusing on the complete pixels of the image. So, the same way is what Transformers is also doing. The same attention mechanism Transformers is also adopting. Let's see, can we apply that to words, right? So maybe for an image it might be easy to implement, right? For an image we can easily spot where to focus because we have been trained in such a way for with many multiple examples from our past experience. But to make it possible in words, it is quite challenging, right? So let's see how to apply that to words, right? So if you see this sentence, the animal didn't cross the street because it was too tired. And when I ask you a question, what is this it referring to? Is it referring to the street or is it referring to the animal? What is it referring to? So how is your approach here? So definitely you will be applying the attention mechanism again, right? You will not be focusing on the words like the, was. It is not significant here. When I ask you the question, what is it referring to? You will be focusing on only particular words, not on the entire words here, right? So is that your approach? Yeah. So the same way how our brain is processing, like focusing on the very important words within a sentence, the same way attention also happens, right? So when I say what does it refer to, we will be mostly focusing on the words like it, street, and the animal. So the it is referring to the animal, right? The animal didn't cross the street because it was too tired. It refers to animal. So do you see a strong connection between animal and it? The line is so intense, right? It has an intense blue color. But the connection between it and full stop is less blue in color. So this is how the Transformers is also doing. This is the most important concept behind Transformers. For us, we humans, we are trying to do it in the no, it's so casual to us. But the same thing, when we have made it possible to a machine, it has started creating wonders. That is the real secret behind this transformer technology. Yeah, so now you have a basic understanding of what attention is all about, right? So, like how we humans focus only on certain things when I ask you a question, the same way the machine will also focus on only certain words, not on the entire sentence. So, this is a very big game changer in the natural language processing space, right? All right. So, now comes the natural question, right? So, how do I teach these to a computer? So you might be thinking, does computer really understand these words? When you say the computer is able to understand my natural English, my natural, my own local language, is it actually understanding it? That natural question might occur in us, right? So actually not. It doesn't even understand any of the words that we are talking. No English word it understands, but what it understands, it can understand numbers, right? It can understand numbers, it can understand mathematical equations, it can understand mathematical algorithms, right? So we have to convert these words into numbers. That is our main task. How do we do that? Can we just have like a dictionary kind of thing, and for each and every single word we have to just convert a dictionary word, I mean a dictionary serial number? That is of no use, right? So what we are trying to do, instead of when I say apple, I'm trying to make the computer understand what an apple is all about, right? So instead of just storing as apple, if I can define about an apple, that the color is red, the shape is round in size, and the taste is sweet, or maybe for the mango it might differ. The color is yellow, round, and sweet. For strawberry it is red, oval, sour, right? So depending upon the color, I'm representing it through a number. Maybe for red it is zero point 0.5 intensity, for yellow it is zero point 0.3, and for taste, if it is sweet it is zero point 0.3, and if it is sour it is zero point 0.1. The same way, how is it converting it as number? That the deep learning algorithm will learn by itself. But for now, just try to understand that for every word, I'm trying to describe about the word and convert it into a numbers. We call these as vectors, right? A collection of numbers in an array we call as vectors. So from converting this single natural language into a numbers, the computer is able to understand our language through the numbers, because computer language is all about zeros and ones, right? So our task is to convert our natural language into numbers, into zeros and ones. So from this it is capable of doing the further processing, and this is also a very big game changer in the deep learning technology. So through this the computer is really able to understand what an apple is all about, right? So this whole thing we call as embeddings, right? So embedding is also a very important concept in natural language processing. So to summarize on this embedding, what are we actually trying to achieve is we are trying to convert a natural language word into number representation using vectors. How are we creating these numbers? We are creating in such a way that the similar words will have similar vectors, and the dissimilar words will have vectors that are farther to each other. For example, if you see this graph, the student and book are lying near, right? But the student and fox are lying in a huge distance, because student and book are related to each other. They will have very less distance between them. But fox and students are not much related. That's why they are having a very big distance among them. So using this vector representation and vector manipulation, the deep learning algorithm itself will learn how to represent these through numbers, which we call as the embedding technique, right? So just to keep it simple, just try to understand that we are converting a word into numbers, which is a vector representation to feed to the computer, right? So is this part clear? And any doubts on this embedding? All right. So if you want to remember what an embedding is all about, we are trying to convert a text into a number representation so that we can feed it to the computer, because computer doesn't understand our human natural language. It understands only the numbers, right? Awesome. So when we consider the attention mechanism in transformers, before transformers was there, right? Before transformers we had this RNN, LSTM and multiple others models. In there it was processing sequence word by word. It will go only in the order the teacher taught the student with the book. It will go in this particular order. It will just see word by word only. But after this transformers came into picture, it is able to focus on the context of each of the word, right? So it has the ability to learn what is the relevance of a single word with the context of the sentence. For example, the word, if I say the word bank, the word bank might refer to a river bank or a financial bank, right? Let me try to put it here. So the word bank might have two different meanings. If I just say the word bank, it might be a river bank or a money bank, right? But if I use in the word, right, I say, no, I have deposited $500 in the bank. So now tell me, what does this bank represent? Does it represent the water river bank or does it represent the money bank? What does it represent now? Which one do you think it will represent? So definitely this bank is referring to the money bank now, right? The bank refers to the money bank, not to the river bank. So how am I saying that? Because there are words like $500 deposited. So with relevance and with the context of these words, I am able to identify that the bank refers to the money bank, right? So the same way, if we take a word with context to every other word in the sentence, with relevance to every other word in the sentence, what is the meaning of the word? What is the context of that particular word? I'm going to compare with each and every word and try to understand that, which was not possible before transformers. But it is possible with the attention mechanism in the transformer, right? So, what does the attention do? The attention is capable of mapping which is relevant to which other word. If I have to focus on the word student, I will also have to focus on the word teacher and the book. For example, if I have to focus on the word bank, and to classify if it goes to a river bank or a money bank, I will also have to focus on the words deposited and $500, right? So, the same way in transformers, if I have to consider a single word, I will have to give my attention to other words in the sentence also. So, this is the major, very big concept of transformers, right? So let's see how it is getting applied in the transformer. So the same example, if you take, the teacher taught the student with a book. And then if I take the word taught, the taught has higher significance to teacher, student, and book. It will be very less significant on the words like the, with, but it will give more importance to teacher, student, and the book. Also, if I consider the word book, it gives more attention to the word teacher, student, book, all of those words, right? So, the similar way for each and every word, I will do a attention mapping, right? If we combine like for eight words here, including the full stop, if I combine all of these, I will get this attention map, right? So with this attention map, now I will know if I want to understand about this word book, I need to first put my focus on the words teacher and the student, right? So maybe what do you think could be other no synonyms of book, right? Book could be it could be a textbook, or it could be booking a ticket, right? Here, if I have to differentiate if it is a textbook or booking a ticket, I have to refer to the words teacher and student. If I refer to teacher and student, I'm confident that it is a textbook and it is not booking a ticket, right? So this is all about attention. So I think with this you would have a very clear understanding of what attention is all about, because attention is base of the transformer technology, right? This is the key attribute of transformer, and this is the one single game changer that revolutionized this space. All right. So let's also try to understand the two different terminologies, that is attention and self attention, right? So what is attention? What is self attention? Both are almost similar, but in attention, there will be a comparison between the input and the output. For example, when I gave you this task for reading comprehension, where I gave you a question like, what did Mr. Frank press? You gave your attention to this first line, Mr. Frank pressed the white lever. So the attention from the input to the output comparison is, we call it as attention, right? But if the attention is within itself, if the attention is within a single sentence itself, we call it as self attention. For example, when we saw this example, what does it refer to? It refers to animal on the street. It refers to the animal. It gives high preference to the animal, high importance to the animal, right? So if we do it within the sentence, we call it self attention. If we are doing it from input to the output comparison, we call it just the attention. So like to make it even more simple, this is inter and this is intra. Within a sentence, if we do, we call it self attention. And between the input and the output, if we do, we call it just the attention. And transformer is focused on the self attention. Transformer is based upon the self attention mechanism, right? We'll try to understand this with this representation. So, as I mentioned, we can consider X as the input. So if it is processing this X input and applying some attention layer to produce a output Y, we call it attention. And if it is not concerned about the output, it is just concerned about itself. About the input itself, it wants to derive further more information, and it is processing and applying some attention layer. We call it as self attention. You can compare it to the previous one. If it is between the input and the output, it is attention. If it is within itself, within the one single sentence itself, it is self attention, right? So with this, we are good to learn about the transformer architecture, right? So far we have seen what are all possible with transformers, what is the base concept behind transformers. Now we will go try to do a little technical understanding about this. This will not be very much technical, but it will be a beginner friendly way of technical things. And so far, this has been the most popular image in the natural language processing space. So any NLP paper or any NLP recent models, right? They will definitely have a reference to this image. If you want to, do some more processing or career based out of natural language processing, this will be your go-to image. You will definitely, have a reference to this at least once in a week or once in a bi-weekly. So let's try to understand this architecture. Maybe at first glance, this might seem intimidating, right? The only thing which we learn so far is this attention. Look how many times this word attention is being repeated. 3 times, right? And it is multi-head attention. So let's try to simplify this. Let's try to understand this in a very simple way. So this bigger architecture, we have tried to simplify using the smaller representation. So the references to all these architecture, to all these illustrations I have given in the last slide. You can refer to those references. So as I mentioned, transformer will have two parts, which is encoder and a decoder. And then we also saw about what is embedding all about. What is embedding? We are trying to convert our natural language into numbers, right? So that is embedding. And what will the encoder deal about? The encoder will deal about the input and the decoder will deal about the output. So all these basic terms we just saw, right? I think by now you are able to understand what is embedding, what is encoder, what is decoder, right? So to repeat, what is the embedding? We are converting a word to a numerical representation. What is encoder? It tries to handle the input so that the decoder will understand it. The decoder will take the input from the encoder and it will give the output which we expect. All right, let's try to understand step by step. What is the first step is, for example, if we are taking a sentence like the teacher taught the, what is the first step? We have to make the computer understand our natural language. The natural English, we want the computer to understand it. So we are converting it into a number, right? It will convert to a reference number, like a dictionary lookup. It will convert to a number, which will get converted to a vector representation. So what is a vector representation? If you remember from the previous slide, we are converting a word into vectors, which will describe about the word itself. Like the same way the teacher taught the, we will convert into multiple vectors so that the computer will actually understand what it is all about. Right? So this part is clear. So first step is we want to convert from a word to a number representation. So after that, we are converting this input to embeddings through positional embedding and token embedding. So what is a token embedding? We are converting this serial number into vector representation. That is what. What is a serial number? For example, if I ask you where is the teacher in the Oxford Dictionary, if you say me that it is in the page number 500, that is the serial number, token number for this word. Likewise, it will also say if you want to see the teacher, refer to this page number 879 and you will see this vector representation. And we also have positional encoding, which will say what is the position of a word in that sentence, right? For the position will be 1, for teacher 2, taught 3, the 4. So the position also is getting embedded in this vector, which is the position embedding. So the meaning of the word along with the position of the word is getting embedded and sent to the encoder. Clear? So we have this encoding layer. After receiving this embedding, it will apply the self attention. What is the attention? Instead of focusing on each and every word, it will focus which one to focus on. Right? For example, we saw the bank. Does it refer to the river bank or does it refer to the money bank? It has to see through the multiple examples, right? Let me try to bring it up. Yeah. Is it referring to the money bank or the river bank? It should refer to the words deposited and $500. Only then it will understand it is a money bank, right? So the same way the self attention is getting applied here. All right. So we apply self attention layer to understand about each and every word in the sentence, to understand about each and every context of a word in the sentence. All right. So there is a concept called multi-head self-attention. So do you know this movie? How many of you have watched this movie? So this is a movie called Endiran, right? It was also in multiple other Indian and other languages. So here, if you see the robo itself will create multiple other robots. And each and every single robo will have its own task. One will be involved in cleaning, one will be involved in driving, right? So the same way, within self-attention, we have multiple head self-attention, right? So in one of the example we saw, to understand about the bank, it has to see about the deposited and 500. So that will be the task of one single robo. The next robo, the next self-attention model, it has to identify and capture some other nuance about the grammar. And the third robot is responsible for, you know, understanding about the sarcasm in a sentence or understanding about the pun in a sentence. So all those nuances it has to understand. And the fourth robo will understand about different things. Fifth robo will understand about rhyming words, and the sixth robo will understand something about the English grammar, right? So each and every single robots here is assigned for a specific task, but what is it actually observing, we really do not know. That we cannot figure out, but it is capturing some different nuances about a sentence. In the same way, we have multi-head self-attention. Each and every head of the self-attention is capturing different complex nuances about the English language. That is all about this multi-head self-attention. Is this clear? What is self-attention? If I have to understand about the word bank, I have to look within my sentence about the word deposited in 500. Likewise, there will be multiple other complex things in English language or any other language, right? So all those nuances, the multiple self-attention robots or the multiple self-attention models to say, it will try to understand. This is the key thing of a transformer technology, right? So we have this multi-headed self-attention which will understand about the words in a sentence. What happens after that? So in the encoder, this will get encoded in a format that the decoder will understand, and some text will be or some numbers will be sent to the decoder. So after reading these numbers, there will be a neural network, a deep learning technique. By seeing a number, it will throw a output. So this neural network is trained in such a way, right? If you see this output, input, you have to give this output. If I ask you, how are you doing? You have to say, I am good. If I ask you, what is the time now? You have to say the current time. Likewise, this neural network, on seeing a particular input from the encoder, it will throw a particular output. Is this clear? So this is what the neural network will do. So what has the encoder has done so far? So the transforming the input in such a way that the decoder will understand is what the encoder has done. Right? So the decoder will throw output by output, and every time every word will be passed to the encoder again. I mean the decoder again. So, with reference to the input from the encoder and also the reference from the output from itself, the decoder will try to give the output every time. So, its single purpose is to keep predicting the next word or the next output. So, we'll try to understand this using an example. Maybe for the first time, this might look very complex, but we will just try to simplify it using an example. So, any questions so far before going to the example? Do you have any questions? All right, we'll dive into those examples then. So, this is a translation technique, as I mentioned, right? What does a transformer do? It will transform one sequence into another. The same way, we are trying to do a translation. So, this is a French sentence, J'aime l'apprentissage automatique, right? So it has three different parts: Jaime, and then apprentissage and automatic, right? So three words are getting converted as tokens, like the page numbers, and getting converted as embedding. And the encoder will do the self attention, and it will pass to the decoder. What will the decoder do? The encoder has converted it into a form which the decoder can understand, right? And then it has generated the first word. So the first word of it is again sent to the decoder again. So now it has two input, not one input but two input. What are the two inputs? One from the encoder and the second input from itself. The first word it has predicted. The output of the decoder is the input of the decoder also. So using this, it is again and again keep on predicting the next word. And finally, it has predicted, I love machine learning. It has translated this French sentence to an English sentence. Word by word, it has predicted, keeping two inputs to the decoder. What are the two inputs? One input from the encoder and the other input from the decoder itself. What was that? It was the previous word which it predicted, right? So this is one of the simple example of transformers. So by sequence to sequence, it is predicting, right? All right. So now we will come back to our architecture. So we have seen the simplified form of it, and we also saw a simplified example of it, right? So now we will try to understand this architecture of transformers. So the small part we saw. Let's see let's try to decode the terms here. So first the input goes to the transformer and it gets converted to the embedding. What is the embedding? We are converting the human language into numbers. So it is getting converted as embeddings, and the positional encoding is also getting added. The position of each word, that information is also getting added, and it is fed to a attention mechanism. What is the attention mechanism? It will know the context of each word, which word to give more importance to if I want to understand about a word. For example, If I want to understand if a bank refers to a river bank or a money bank, I have which word should I give more attention to? Likewise, there will be multiple head attention, like the robo example that we saw. And then after this attention is getting applied, it will be passed to a feed forward layer. What is this feed forward? It is just a neural network, right? So this neural network, upon seeing these input, it will transfer this into a format which this decoder will understand, right? So what does this decoder do? It will take the input from the encoder and it will try to throw a output. And whatever output it is throwing will again be a input to the decoder itself. So that output will get converted as an embedding along with the positional reference, and the attention will be applied, and attention from the encoder will be applied. And this neural network, if I see such a input, I have to throw such a output, and the same will be performed again and again till a conclusion is arrived, right? So this is the architecture of transformers. Even though this looks so simple, just with this attention and just with this multi-head attention, it has made a lot of wonders, like text to code, text to image, text to summary. All of those, this single architecture is capable of doing, right? So, any questions on this? Okay. Even if this looks very complicated, right? You can always refer to this simple architecture. We have the encoder, which will convert the input to a no machine readable format, and the decoder will get the help of encoder, and it will throw the output. So one input, one form is getting transformed into another form output. So the input could be a text and the output could be a video. Input could be a text, output could be a code, it could be an image, it could be a summary. Or the input could be just a keyword like global warming, and the output could be a whole big blog post itself. Right? Cool. So we'll try to understand different types of transformers, right? So after transformers, there are a lot of variants that evolved. So we saw encoder decoder architecture, right? So there are multiple variants where they have used only encoders. So only using encoder, they have a variant called BERT. So this BERT was the state of the art model when it got released, and it paved way for multiple applications. So what does the encoder do? From a single input, it will transfer into a format of creating a deep representation of the input, right? So one such application is span-based question answering. If I give a paragraph and a question, it will tell me which one to focus on. It will just extract the particular area to focus on. Like here, what is the capital of Germany? It will tell me what to focus on. The answer is Berlin, right? That is the key functioning of an encoder, right? The encoder will apply the attention and it will give a deeper representation of the input. And we also have encoder decoder models where we use both. One such model is T5 models. There are a lot of variants of T5. If you see here, the translation is happening from English, it's getting converted to French, and from sentiment analysis is happening, sentence scoring is happening, and text summarization is happening, and a lot of transformation is happening. This is also one another variant of transformers. And we have decoder only models, which is the famous GPT models. So what does the decoder do? It will take the input. Upon seeing such a input, it will throw a output, right? So it itself will have the attention mechanism, its own neural networks. So from the input, it will throw up certain output. So if it is a text, it will convert to a text or code, or the depending upon the prompt, it will do. So GPTs are an example of decoder only models, right? So if somebody is asking, is GPT an encoder model or a decoder model? GPT is a decoder only models, right? All right. So this is the famous and the paper which has been a big game changer. We will try to do a walkthrough of this paper, right? I think everybody here, you should definitely read this paper at least once, even if it looks sometimes intimidating at the first glance. If have the skill of reading research paper, that's also very that itself is a skill. If you like go through multiple papers, you will naturally learn to understand multiple research papers. So let's try to go through this paper. Yeah. So this paper, Attention is All You Need, is where this game-changing transformer architecture was released. If you see, this is the architecture diagram we saw, right? So this architecture was introduced in this paper. So this paper was published in association with Google and University of Toronto. Aiden from Toronto and Ashish Vaswani from Google Brain, they were the key contributors to this paper. So in the abstract, they will try to explain what is the encoder decoder and the attention mechanism, what are they trying to achieve, and what is the evaluation metric of these models. And this introduction, they will mention about what happened before transformers. They had RNNs, LSTM models, and what is the problem that is being happening. Like it is not able to, retain the information for a longer time. It is not able to capture the context of a word, right? So that's what they are trying to solve. And they will also explain about self attention and retaining the memory, understanding about the context and how are they going to represent the input, right? And we have the model architecture. That's what we saw in the previous slides. So we have the encoder decoder stack and we have the attention stack. So the attention itself is a neural network. It itself will get trained. So for example, like which word to focus on itself is a big task, right? So that itself it has to learn first which one to give more attention to. That itself is a neural network which will get trained. And we have multi-head attention, like each and every single robot does a different task. Likewise, they have multi-head attention. They concatenate multiple attention layers which lead to the multi-head attention. And we have the embedding layer, positional encoding, like it will say about the positional information of each and every word in a sentence. And why do we need self attention? Like the example we saw, right? Like does a bank refers to a money bank or a river bank? We need the self attention. Within the sentence, we'll have to focus. And then we mentioned about the pre-training, right? They have pre-trained using multiple data, and then they have evaluated against different tasks like translation, question answering, multiple tasks they have evaluated. Yeah, so this is such an interesting paper which has no gave birth to multiple other models and multiple other applications, and whatever examples we saw all are dependent on this particular paper. And they will also explain about the attention mechanism, right? So if you have to understand about the making word in the sentence, you will have to give more focus to more difficult, 2009, all those. Like if I ask a question, what it refers to here, we will have to focus on the word law and application. The law will never be perfect because its application should be just. So it is evident that it refers to law, right? So you can go through this paper if you want to, develop your career out of natural language processing. It's definitely the most interesting time in natural language processing, and this is also one of the important paper. Just give it a read in your free time. So yeah, that's all I had. So okay, I'm open for any questions now.
Just a minute. Yeah. Thank you so much, Anika, for providing such valuable insights. And I'm sure the learners must have learned a lot from you. So, yeah, it's time for our question and answer round. And throughout the session, many of you have submitted questions, and we have selected a few to address now. So, I'll read out the questions, and Ms. Chandnika will provide you the insights. So, yeah, I'll just read the questions now. So, first question for you, Chandnika, is if I learn transformers, what are all the job roles can I apply for? Yeah.
All right. So transformers have become like the foundation for multiple techniques, right? So if we take even the GPTs like Chat GPT, its base is transformers, and almost most of the industries and many applications are trying to adopt these transformer based applications. Like even if you are a developer or a programmer, right, the co-pilot, the code generation is going to transform that industry. So having a base knowledge about this transformer, not even if not much into technical things, but even the base understanding is definitely essential for any role, any AI or ML based roles. But if you want to go deeper into a particular field like natural language processing or a computer vision based engineer, this deeper understanding of transformers will be much helpful. Uh, Vinodini, I think you're on mute.
I'm sorry for that. Yeah, okay. Next question is what are some practical considerations or challenges when deploying transformer models in real world applications? Yeah.
Yeah, that's really a great question. So the problem arrives when we want to productionize these models, right? So even though we see high quality results, when we go to production, lot of issues happens. So first thing we'll have to consider, is this suitable for my use case? So, like I mentioned, there are multiple variants within transformers, right? There are encoder only or decoder only, encoder decoder only models. So, the step one is to identify which model will be relevant to our own use case. So, depending upon that, we'll have to develop. And also, after we evaluate the models using the training data, we'll have to make sure that we are continuously updating the model. So for that, we'll have to do a fine tuning thing. So two things we saw: one is pre-training, and the other is fine tuning, right? So even though we have the pre-trained models available in the public repositories, if we want to productionize it for our own data, we'll have to do a fine tuning for higher performance. So iterative fine tuning is where we'll find a lot of challenges in terms of data collection, data processing, and tuning the model to our own data. So in those spaces, we'll find the challenges. So it's highly important that we choose the right model first. Yeah.
Okay, thank you for that answer. And we'll go to the next question. So, the next question is: are there any limitations or drawbacks of transformer models that I should be aware of? So, yeah.
Sure. These are really interesting questions from the participants. So, yeah, we saw a lot of glories of Transformers, right? But there is a very, not a major drawback, but a small limitation in Transformer. Not just in Transformer, in deep learning, I would say. It is the model interpretability. So, what is model interpretability is like if I ask, how is this model predicting such a thing? Right? Like I mentioned it as a black box model. We don't know what is happening inside. For example, if I give the text as I want a image of a cat, it will bring up an image of a cat, but it might be a brown cat or a black cat, but it will not be able to explain itself why it has given the color of the cat as black or brown. What is happening inside the model, we do not know. If a model can explain itself how it is deriving to an output, we call it as model interpretability, which is very essential if we are going to the business level, right? Maybe for our public usage, image to, text to image, text to video could be a casual thing. But imagine about the business use cases where a single data point could be a revenue generating thing, like the forecasting or the revenue prediction. Or for example, in e-commerce or many industries, they are using data science and AI models to predict the sales, to forecast the sales, right? The business cannot completely depend upon a black box model. They will expect the model to explain itself. This is why I'm saying you have to consider this decision. This is why I'm saying that you have to consider this strategy, right? So that
Okay.
is very essential in terms of business. The business leaders will expect for this explainability in AI models, which is not possible in deep learning. Transformer is a deep learning technology. Like the simple example we saw, right? If I ask you why do you like a person, why do you dislike a person, you
Yeah.
cannot really explain yourself. Some subconscious things are happening, but business will not depend on that. Business needs specific data points, explainable models, where this cannot be this is a very small limitation of transformer. Again, it depends upon the use case. If you have a use case, for example, in the gaming industry, right, we saw the video generation. There I might not need the explainable models. I just need a good animation, a great video generator. There, this could be a game changer. Yeah.
Yeah, thank you for that answer. And we'll go to the next question. So yeah, the next question is: how can one get started with implementing or using transformers in their own projects?
Awesome, sure. So this was a very beginner-friendly introduction, right? So just the technical things, what is possible using this transformer. So this transformer we can download from the open repositories. From there is a
Okay.
site called Hugging Face. I think most of you would have heard of it, or just Google for transformers. From Hugging Face, we can install this library. You can just do a pip install transformer. Using this Python library, you can implement multiple things. It's just a few lines of code. You can make wonders. The English to French translation, it can be achieved only with 5 to 6 lines of code. You can refer to Hugging Face repository. It would be a simple implementation.
Okay. Okay, nice. Thank you for that. So yeah, next question is: what are the main advantages of using transformers compared to traditional machine learning models? So this is one question.
Sure. So, as I mentioned, transformer is a deep learning technique, right? So, there are a lot of advantages of deep learning over machine learning, and also there are subtle limitations with deep learning also. So, the major advantage of machine learning and deep learning lies in the feature selection, right? So, if you're familiar with machine learning, you would know there is a process called feature selection in machine learning. For example, to make it simple, if somebody is using a Netflix site, right, or any other OTT platform, if I want to do a recommendation to a group of people, consider there are person A and person B, and I want to recommend movies that are to their interest. So to describe about this person A, I will describe about this person as he is about this age, he is from this locality, his friends are watching these, and this is his past watch history. And the same feature I would use to explain about the person B also. So using different factors like these, I would recommend the movies. So whatever factors I mentioned, right, about the age of a person, about the watch history of the person, all of these are features. So to a machine learning model, I will say you have to focus on these features and make a decision, make a recommendation to the people. But what if I had missed a feature? What if there is some complex feature? Like if the person is watching in a weekend or day, or what is the mood of the person today, what if I have missed that? It should not be dependent upon my a human decision, right? So that's where deep learning comes. So that deep learning will figure out what factors it has to see to recommend a movie to this person. We don't have to tell to the machine what factors you have to do, I mean consider to take a decision. The machine itself will do that task also. So that's where transformer comes in. If I have to convert a text to a video, I cannot define certain factors. I cannot every time tell the machine this is the feature you have to look. It is something that has to some black box model it has to do, right? So that's where transformers will be helpful, where we cannot explicitly teach a machine. The deep learning transformers itself will learn what to do. That's
Yeah.
the major power of these transformers.
Okay, thank you for that answer. One more last question we have, that is, okay. So learner is asking, can I use ChatGPT to build project in office work? So could you please answer that?
Okay. Sure. So it again depends upon the organization you are in, right? So most of the organizations are slowly started to adopt ChatGPT using Microsoft platforms. So Microsoft is hosting Azure cloud services through which we can access OpenAI services. But still, few organizations are hesitant to utilize it for their privacy reasons. So there are a lot of open source models available, similar to ChatGPT, like Mistral, the Llama, and many other things are available, and multiple competitors are there. But if your organization is allowing this Microsoft Azure AI services, you can definitely do it. Yeah.
Okay. Okay. Thank you for your answer. So that's it with the question and answer session now. So now it's okay. So these are all the questions we have. So thank you for your questions, everyone. And as we have come to our end of our session, I want to extend my sincerest thanks to our wonderful guest for sharing her knowledge and expertise with us today. So thank you so much, Chandnika, for coming here and explaining so much to us and sharing so much knowledge with us. And we look forward to future opportunities to learn from you and continue benefiting from your wealth of knowledge. And thank you so much for coming. And please, for participants, please note a few more sessions are planned and curated, especially for the career fair. So I I'll be requesting you to be active in mails and don't miss out this enriching sessions. And thank you so much, Chandika, for coming. Thank you. And yeah, thank you all for being a part of this session. And I hope you found it as enlightening as and valuable as I did, because I learned so much from you, Chandika, today. And remember to keep exploring, learning, and growing. And until next time, take care and goodbye, everyone.
Sure.
Bye.
Yeah. Thanks a lot. Bye.
Thank you. Thank you.